Alright, today's lesson is 6.4 and 6.5, properties and conditions of rhombuses, rectangles, and squares. So each one of these quadrilaterals is a special type of parallelogram. So here are a few definitions. We have the definition of rhombus, and that's what we discussed in class. This is a rhombus, and what makes it distinct is that all four sides are congruent. All of these, like I said, are parallelograms. A rectangle is a parallelogram, and all four angles are right angles. And a square is a parallelogram where all four sides are congruent, as well as all four angles are right angles. So let's look at some properties of rhombuses. We have two theorems related specifically to rhombuses, and again we drew a picture in class on the board today and talked about it. Here they are in writing. So theorem 613 says if it's a rhombus, then its diagonals are perpendicular. So you'll need to write that down, and then in pictures, if it's a rhombus, and we know it's a rhombus here, this picture tells us because all four sides are congruent, then we know that its diagonals will be perpendicular. So in particular, this situation, this theorem is indicating that this diagonal here, so we'll label A, B, C, D. So diagonal AC is perpendicular to diagonal BD, and we can write that as AC is perpendicular to BD, and those are both segments, so we put the segment symbol above. Theorem 614 says if it's a rhombus, then its diagonals bisect a pair of opposite angles. So here's our picture. If it's a rhombus, then the diagonals bisect a pair of opposite angles. So that means this angle here and this angle here, and this angle here and this angle here would all be congruent, as well as angle 1 and angle 2 here. We're going to number these angle 1 and angle 2, and angle 6 and angle 5. So we'll call this angle 7 and 8, and we'll call this angle 3 and 4. Now we're going to label each one of these. So 3 and 4 are congruent, and 7 and 8 are congruent. So I'm going to use different colors to represent that. Angle 1 is congruent to angle 2. Down here, angle 6 is congruent to angle 5, as well as angle 3 is congruent to angle 4, and angle 7 is congruent to angle 8. Now let's move on to theorem 615, which is a property of rectangles. So in theorem 615, it says if a parallelogram is a rectangle, then its diagonals are congruent. So that is not necessarily a property of a rhombus, but if it is a rectangle, such as this, then we know that its diagonals are congruent. So here we have our rectangle, and labeled with these 4 right angles, we know it's a rectangle. And then our diagonals are congruent, so we're going to label this A, B, C, D, and we can say A, C is congruent to B, D. Now when we get further along, we are going to show the proofs for these statements. So this provides us with a great foundation for making statements and using these properties to solve different types of equations to find missing pieces for these parallelograms. Next, theorem 616. So as we flip the page, if you were trying to find some extra examples or extra information, this would be found in section 6.5 in the textbook. And theorem 616 says that the diagonals of a parallelogram are perpendicular. So if the diagonals of a parallelogram, we can just draw a symbol there. If they're perpendicular, we can use a symbol there. Then we can say the parallelogram is a rhombus. So again, multiple learning styles. We can draw this in pictures. So if ABCD is a parallelogram, remember all capital letters we use to represent a quadrilateral. If ABCD is a parallelogram, then and AC is perpendicular to BD. So we're establishing our if statement here. So we have A, B, C, D. We've got these diagonals here. Which it says in our if statement that those diagonals are perpendicular. To be a parallelogram, we need 2 pairs of parallel sides, so we can label that with our arrows. Then ABCD is a rhombus. Right, so by definition, a rhombus is a parallelogram with all 4 sides congruent. Theorem 617 says if one diagonal of a parallelogram bisects a pair of opposite sides, if one diagonal of a parallelogram bisects opposite sides, then the parallelogram is a rhombus. That says then the parallelogram is a rhombus. So here we have our A, B, C, D parallelogram, defined by the fact that it has 2 pairs of opposite parallel sides, and this diagonal here is going to bisect the opposite sides. Angles 1, 2, 3, and 4. So these are bisected, as are these 2 angles. So we say running out of space. If angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, then we know ABCD is a rhombus. All sides congruent. Last theorem, 618, says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So here you have, so if ABCD is a parallelogram, and we have, again, ABCD are standard for our definitions here, and AC is congruent to BD, so here's AC and BD. If those are congruent to one another, then we know that ABCD is a rectangle. So there you have it. We have new theorems, 6 new theorems, starting with 613, 14, 15, and then 16 through 18. I'm going to do a few examples here for you. Example 1 is asking us to find the measure of each of these angles. So you can see one angle is labeled, and we need to find the measure of the others. So if this first angle is 58 degrees, what do we know to be true about these other angles? Well, we do know that the measure of angle 1 is 90 degrees, so we know that this one's 90 degrees because of our property. Since this is a rhombus, so we know that this is a rhombus. I'm going to label that. We only know it's a rhombus because I just told you it's a rhombus. So angle 1 is figured out. So if angle 1 is 90 degrees, each one of these angles, they're all 90 degrees. So then the question becomes, how do we get to these other angles? Well, if you think about this parallelogram cut by a transversal, we know that this angle 58 here is going to be congruent to angle 2. So now we know that the measure of angle 2 is 58 degrees. Now, because of our property that says these diagonals in a rhombus bisect opposite angles, we know angle 3 is also 58 degrees. And then the last one we need to figure out is angle 4. Well, we know that this angle here is 90 degrees, so therefore these two need to add up to 90 degrees. So we just need to subtract 58 from 90 degrees, and we get 32 degrees. So then the measure of angle 4 is 90 minus 58, which is 32 degrees. So now we have the measures of each of the missing angles. For part B, since this angle here is 104 degrees, we know that these two angles need to add up to the remaining number of degrees after we subtract 104 from 180. So if we subtract 104 from 180 degrees, then we get 76 degrees. Now, we know that these angles are going to be congruent because this is a parallelogram and cut by a transversal. Those are called alternate interior angles. We also know that these two angles are congruent because this diagonal bisects opposite angles. So therefore, all of these angles are congruent. So if we just figure out, we just need to divide that 76 by 2, and we'll have the measure of each one. So 76 divided by 2 is 38 degrees. So therefore, the measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals the measure of angle 4, and all of those equal 38 degrees. So you have a couple more examples to do. I think you can do example 2 on your own. If you pause here and you set this up, I would first solve for x by making these two congruent. Since this is a rhombus, we already know that all sides are congruent. So make an equation that says 4x plus 3 equals 15, and then another equation that says 3y equals 5x. But substitute your x value in for this x, and you'll be able to solve. Here in examples 3, 4, and 5, you need to again apply properties of your special parallelograms. So we know in a rectangle that these two angles would add up to 90 degrees. So I need to make an equation. We've done this before in previous sections where we know the two angles are complementary, so we add them up, set them equal to 90 degrees, and then solve. For the rhombus, we know that the rhombus has these two diagonals that bisect one another. Therefore, since this is a triangle, and the sum of the measures of a triangle is 180, we know that these two angles then must also add up to 90 degrees. So the equation for this, 8x plus 7 plus 3x plus 6 equals 90. And we could solve for x again. Lastly, we have this rectangle question, and we established in the previous, let's see, our properties of parallelograms allow us, let's see, to say, when we have this rectangle, these are, AC is congruent to BD, we also know that since so we have the diagonals are congruent, and so we have the reverse of that, so those are the two pieces, but it's also, we know since it's a parallelogram, right, that these two, let's see, these two angles would be congruent here, And then also, if we went this way, we would have this angle here congruent to this angle here, and we know that, well, let's see if we can make those two equal to one another. So if this side right here is congruent to this side, these two angles are congruent. This forms an isosceles triangle, is what happens. So what we can establish then is that 4x minus 12 equals 3x plus 4, and solve for x in that question. If you'd like further examples and explanations, you are welcome to check your textbook in sections 6.4 and 6.5, and good luck.